Yeah.
Trying to get 80 people in, to be honest.
You can't get into that building.
No.
That's fine.
Yeah. No, it's a problem. Means that people have to try and come in with experience of what they
Yeah, I mean,
sorry again, Kale. Must have been very traumatic. Bloody hell.
Yeah, I never did change that. Right. Oh,
upstairs or downstairs. Just keep on going round. They will arrive either at the tin coffee or. The other thing is that looking around the um, we open, we open and ensure that have we got somebody sat in that room?
I think that's what Graham and Finn said, yeah.
Because obviously what we because it's difficult, we can't just say, don't leave anything valuable here. Because what's the commercial people might be looking and saying, well, we have to put out 60,000 pounds worth of kits. But in general, I think people should just be going with anything online and there are other users. But everyone's quite, it's all straightforward. The only thing I'm just slightly worried about is potentially some students coming in to say that we're not here. But there's enough signs of problem, elsewhere.
Yeah.
I thought you were sleeping in the office last night.
Yeah, so did I. It was a bit easier. I basically went home, changed my clothes, had a shower, and go straight back again. I kind of forgot I was in the workshop. Not forgot.
Well, be careful because it's now warming.
Yeah.
No voice.
No voice.
Oh, the host is on.
Yeah.
Don't say anything. I suppose it should be like a buttery arcade or something. Just put something over the top, so we'll. No, better not. Have you got any names yet, John?
I had a lot of names.
The first person I walked into, I thought, should I? Yeah, okay, why are you talking to me? And just thinking, oh yeah, I think we have to talk.
It's taken 20 minutes to get this bloody back up.
Oh really? Well, we're blaming the organisers. Yeah. Good find them, blame them.
Yeah, have your beers open in it?
Oh?
Have your beers
No,
open?
it doesn't. It's separate.
Oh, right.
Yeah, and these fall out.
Oh, excellent. Well, that wasn't my, someone else's department.
Yeah. Morning. It's a bit smart.
Good chance to dress up.
Have you registered?
No worries,
Are we till then?
I'll watch it.
Yeah,
It's not
go straight down and turn right and there. Yeah.
I'm going to go and get some pickles.
Yeah.
Oh,
The problem is if you talk nice and
Jimmy, can I take your stick out?
Yeah. Is it copied to?
No.
Oh,
How
yeah.
you doing?
Yeah. Been thanks for the
Yep. Finished on the 10th. That's good going.
well, I've been in the field the last couple of weeks last week. Got in the office Monday afternoon.
Do you want to see if it works? There's a wireless mouse and there's a laser pointer, so I have to draw your attention to this side.
Not point at another individual. Great. And will this move back and forward through the slides as well?
No, that won't. So you need to use just that's what we're using the wireless mouse for. Other side. Should it be good? Over here. Oh, it is there. Yeah, it will now. The problem was with two screens.
That's enough for me to read without putting my glasses on as well.
Does it show you on the screen as well, or does it show you the next slide? It does show you it. Yeah. That'll work.
Yeah.
Check
It's on the desktop, isn't it?
it's it's folded on the desktop called in that folder, just got they look at presentations.
Great.
All right.
I think we'll both be starting with the very similar talks to the ones we gave at the Archaeological meeting. So anyone who was there will be like, this is quite familiar. I kind of feel like.
I know, yeah. Unfortunately, I've rehashed it a bit and put some extra bits in it, and because that was a bit more Scottish based, so.
Oh, you have actually. Yeah. I took the word Scotland out once.
Yeah.
Scotland.
I've not really been in the office the last few weeks, so I've not had time to.
Oh, thanks.
Not had time to do anything much.
That's my lid. Yeah, Graham and I got back from survey yesterday at 4 o'clock.
Have you looked at Durham?
Yeah.
Sorry, a man going around last week and the other day.
Gone at the day.
Especially plants like that.
It's in the signs recently. No, the ones outside have got cags. I've got that.
Right. There's nothing in the building.
They just say tea, coffee.
Yeah. They could be just generic.
Yeah, that's true.
I could just print a bit and stick on the bottom.
Yeah.
That sounds
Do
good.
that.
I could do that.
Thank you all.
As long as you guys just gonna get.
be worth putting something on already. There's that on.
No, I mean my
Oh,
presentation.
yes. Yeah, that would be good. Yeah.
I can get rid of this one.
Yeah, that's what we've got. It's
And then I've got loads of copies of the guide to good practice.
Oh, right,
giveaway.
okay.
So I don't want to carry them around now.
just one label, Smith.
Yeah, exactly.
How many copies have you got?
20.
All right, okay.
Looks more than it is.
Should I just put some on all the benches? Or I suppose you.
No, I think I will leave them here and then people have to grab them.
We'll get them at the end.
Yeah.
Yeah, okay.
So they are free, but I would be happy for any donations, let's put it this way.
Oh, right, okay.
Because they have costly £6 each, so it would be good to have
Right, yeah.
no donation. Thank you. Alright, that's sorted.
Awesome. Right. Who else will I Here, Ken Hamilton.
Haven't seen Ken yet. Is he here?
Ken is here, yeah.
Oh, yeah. Right, there you go. Very good.
Awesome.
Thank you. All set, exactly.
Just gotta put away.
they need to do is provide companies to industrial companies to fund PhDs.
Yeah.
They already do that.
Yeah. There's also a laser pointer, but they'll have to bring you to the section of the use of laser pointer sign.
Please use responsibly.
Yeah. It's just
Use them to annoy my kids. Where are we? Got the. That's that one there.
so do you want to just copy that into
Yeah.
There's just, in case it disappears, there's just a folder on the desktop which has got all the presentations in,
Splendid.
just in case someone closes it.
Where's the? Oh, I don't know how to use these modern ones.
We try to do.
Eject.
Oh, right, yeah.
Eject needs to do. We're still on Windows 3.1 in Norfolk, so splendid.
I see, because we get all the stats of people who read all the emails. It's amazing the number of people who are still using 1024 by 768 screens on Windows 95 and all versions of Internet Explorer. I assume that they were all county-constants.
Yeah, probably. On my home computer, the one I use at home, my father bought that. Found it in his car when he died, and it still had Windows 98 on it.
Oh, wow.
And it had a little sticker on the top of it saying "Now with new Windows 98." So that dates that, but I still use it. It works fine. It's just got a horrendously stripped down version of Ubuntu.
Oh, right, yeah.
Definitely not get too cold.
Finn! Finn! Where's it? Okay. Oh, there it is.
So technically, how long are you going to talk?
15 minutes.
15 minutes, and then we have our 15 minutes.
It's 15 minutes talk, 5 minutes for any clarification.
Do you want to go at the end?
Yeah, just if there's anything immediate that people don't understand. We've got we have got a 15-minute exercise.
Okay. Where?
Vince is getting it. Obviously,
Okay, so that means I don't even have to.
I know it's like because it takes that kind of awkward standing up and yes.
Funny dictate.
Well, old school. Yeah. Finn, being the scientist that he is, celebrated. It's designed for school children, hence the slightly alarming colour. No, no, you do have to keep an eye on it.
Yeah.
And it's not gradated either, so you have to guess. I know, yeah. We're not far off. Thinking always sneaking. Yeah.
Good morning, everyone. Welcome to the hub of our conference today. If you've never been to Bradford and Archaeological Sciences, please do come back frequently. We're a nice bunch, and we've got a good session and a good series of talkers today. I've got to do the usual health and safety stuff. There's no fire alarms scheduled for today. If the alarm goes, follow me, okay? I'll be the one who will be shouting academics and children first. You know, right? Just straight out here, down to our left. We're mixing new technology and old school today. The old school is the egg timer. Okay, we've had it calibrated. It's exactly 15 minutes. Okay, it doesn't buzz. But if anybody sees the last grade go down, please feel free to shout out, "Oh, get off the stage!" Okay? The new technology bit is that you know we were oversubscribed for this conference, and we're streaming live, okay, onto YouTube. So anything that you are saying now will be recorded, used against you, and possibly you'll get sued. Okay, so be very quiet. No, we don't want that at all. We actually want to have a proper conversation. Don't feel inhibited. If there is something that you feel that you want to say and you'd rather it wasn't broadcast, then you know just say so. Okay, we can switch the microphone off for a few minutes. I hope everybody's comfortable with that. We've got the way that the sessions are going to work is, as Jimmy suggested, is we're going to have talks, 15 minutes each. We have a few minutes between each talk to have clarifications, any immediate questions. We're off to tea. Basically, the microphone will follow us, I think. Is that right?
Technical department.
Technical department. I think it's going to follow us. So the discussion will also be broadcast. And what we hope is that the people who haven't been able to make it here will understand the fruitful nature of the talks and the discussions as we go through the day. Okay. All right. That's just about enough for me. We're going to start off with Jimmy, who's going to fill in some blanks for us.
Apparently so. Yeah. Sorry, it's me again. We had, unfortunately, thank you. We had one of our speakers had to drop out at the last minute, so I didn't step backwards quickly enough when they were asking for volunteers. That means that this is actually a talk I've given before at a meeting for Archaeological Scotland, which was organised by the IFA Geophysics. So I do apologise if you've seen this before. Some of the content will look very familiar, in fact probably all of it. I've removed some of the references to Scotland, but there are some still in there. What we were trying to do on that day was trying to reappraise the use of geophysics in an area where traditionally it hasn't been used very much. And what I wanted to do was look at the reasons why people in general do or do not use geophysics, and then try and find some case studies that would either support the positive views or perhaps would refute the negative views. So I sent out a quick questionnaire right across the sector to archaeologists, consultants, curators, and other geophysical contractors, just to sort of gauge opinion on how and why we use geophysics. So I'll run through some of the answers that we got, and I'll have a couple of case studies with each one. Those case studies will obviously help us to look at site evaluations, and then at the end I'll just be looking at some of the reasons people give for not using geophysics, and perhaps try and suggest that maybe they're wrong. So, starting off, I'm going to look at a series of different types of sites, starting from the very top level, our guardianship sites, where we have the heaviest controls upon. And obviously here we're saying that any alternative to invasive investigation has got to be a bonus. So in this example, we've got a Roman settlement in South Wales. Excavations have been taking place there from antiquarian period right through to the current day. But obviously there's still quite a few insula which they know very little about. So Insula 1 in the northwest corner, less than a day's worth of magnetic survey. We got some results. We could see some negative features up here which we assume to be building remains. We got a lot of noise down here which was roadside settlement, but we also had a lot of disturbance from more recent features such as a metal pipe running through the site. So we followed up with some GPR survey. We've hawked this one around enough times so you may well have seen it. Again, that was only a couple of hours of data collection with an alternative technique. That allowed very small keyhole trenches to be put in to phase that complex of buildings that formed that Roman villa. So with a very small amount of survey and a small amount of excavation, we've managed to move on the knowledge of that particular corner of the Roman town. So, coming down the level, just to your Commonweal Garden scheduled site. This is a deserted medieval village with scheduling placed upon it. This is a big industrial unit, and what they wanted to do was expand into the field behind and put in new units. Again, not a massive amount of survey, but quite a lot of archaeology. And none of that was scheduled right next door. So is the scheduling going far enough? Can you guarantee that? How are you going to quickly find out whether it is or isn't? So again, on very large sites, you might have a percentage of trenching that you're going to be carrying out. If you can go in perhaps with a geophysical survey first, then you can probably use those trenches more wisely, concentrating on areas where there's clearly stuff has been found, but also being able to test the blank areas. Although obviously the geophysics is going to be an extra cost, it's going to be an extra line on your balance sheet, hopefully the overall cost of the project should be less because of its use. Now I realise, looking around the room, that I am preaching to the converted. An awful lot of you in here are using geophysics very regularly, but you know, hopefully you'll recognise these themes. As I say, originally this talk was given as a kind of showcase, I suppose, for using geophysics more. So then we might have the situation where we've got excavation going on, but the results that are coming out of the trenches are difficult to interpret. And so in instances we can actually go back, survey around it, and very quickly give you the context to what you're finding in the ground. And from a planner's point of view, or a planning point of view, or if you're a consultant on a project, it might be that after you've done the geophysical phase, you can actually start to rejig the layout of whatever it is that the development might be, and just simply avoid some of the clear archaeological features, rather than have to deal with the cost of total excavation or dealing with them in some other way. So for a long time we've just kind of agreed to disagree. Some people think that geophysics is a good idea, some people think that it's a bad idea. Some people sort of just blanketly say, I'm not going to use it at all. That may be for a number of reasons, which I think some of the other talks are probably going to look into. But a common one is, no, it costs extra money in the project. I'd rather just spend that extra money on having trenching done. This is a case from a couple of years ago where we had done an original evaluation survey where it had been requested that we did 1 hectare blocks across the landscape. So this is just one of probably 20 blocks spread around a large area in Essex. Some while later, the trenching strategy was decided upon, and all of these are the trial trenches that went in. And after that phase of work, we got an email from the client saying that due to the some slight complications, they were having real difficulty deciding on what was going on site. And so actually we had to come back and do extra survey round and about the original block over the trenches which they were having difficulty with, try and see if we could help them in any way, shape or form. Obviously, it would have been more efficient and quicker to have done that all at the first phase and just probably go for total survey. The length of time it takes in your evaluation process, but the one thing you might want to try and avoid is finding something that you're not expecting to be there. In this instance, we've got a pipeline corridor. We were asked to survey sections of the pipeline where they thought there were archaeological features. So I don't know if you can see it particularly well, but there is a crop mark in here of an enclosure. We surveyed the pipeline corridor, sure enough, there it is. But we've also got a lot of features that weren't particularly well represented in those crop marks. For reasons I don't fully understand, they decided that they would just move the pipe to the north, not do another survey, and just go for watching brief on that pipeline. At the point where they hit this area, which was just full of burials, pits and all manner of other stuff, they decided that it might be a good idea to try and work out what was going on. The width of the pipe trench was so narrow that it was almost impossible to tell what they had here in terms of features. And so again, it was the extra expense of us having to remobilise, go back, survey again and find out how extensive that site was. The other one is that, well, geophysics, it's a bit unreliable at times. You know, sometimes you find stuff that isn't there, sometimes you don't find stuff at all. Geophysics is just another tool to use in evaluation. It's the same as crop marks, it's the same as field walking. Field walking doesn't work on a particular site. You don't then go, well, I'm not going to use field walking again. So we can have problems with aerial photography, transcriptions can be out. So on this particular site, in red are the AP transcriptions. And then obviously the survey data shows that there is quite a considerable offset between reality and where they were posted. On this site, we were coming back for a quite large-scale development. The client had been a bit savvy and said, we know there's a massive pipe crossing the bottom end of this field. If you could survey up to it and save us a bit of money, we'd appreciate it. We'd prefer just to do the whole field, it's much easier, but you know, the customers are always right. We said, is there any archaeology in the area? Is there anything known about it? Have you done desk-based assessment? Is there other records? Check the HER, things like that. Nothing recorded. So when this pipeline went in, it had a watching brief on it, but had missed the fact that there appears to be an enclosure cutting straight through the middle of it. So again, you know, nothing is infallible. So do we need to reappraise our ideas about whether we should be using geophysics if you are one of that group that has decided that for whatever reason it's not your cup of tea? So the argument, necessity, I've shown that other sources of information can be unreliable, can be misinterpreted, exactly the same as geophysics. But with increased pressure on budgets, whether that is in local government or whether that is for your developers, you know, we nearly need to try and be as efficient as possible, and geophysics gives you a pretty good head start on any project that you'd be working on. Again, we've shown that costs, actually, it is that extra line on the balance sheet, but if you can improve your efficiency, if you can cut down the amount of trenching that you need to do, then ultimately that project should come in at a slightly lower overall budget. Yeah, and much to the disappointment of all concerned in the industry, magnetic survey, for one, is now considerably cheaper than it used to be, owing to CART systems, GPS data collection. When the Bartingtons came in 8 years, 9 years ago, 10 years ago now, that suddenly sped up data collection. So actually, even we are more efficient than we were, and other techniques are becoming more efficient, as some of the talks in the afternoon session will demonstrate. And effectiveness. Again, as I've already said, it's not infallible, we know that, but then no survey technique is. It should just be a tool for your evaluation strategies. Again, this was based in, this talk was originally given in Scotland, so it was talking about the general consensus there is that all geology is bad, but actually, you know, there are plenty of areas where it can be used. So just a better awareness of how it works. So I apologise, this again is another Scottish-based slide where we've said that in Scotland there isn't the English Heritage Science Advisors and you don't have the Ancient Monuments Laboratory. There isn't a definitive point of reference for getting advice on geophysics. However, that statement to a lesser extent could be applied to the whole of the UK. We have less science advisors than we used to. The time constraints on projects these days are such that people phone contractors up and say, I need a survey, can you start next week? Well, the time to get advice on whether geophysics is going to work, which technique you need, isn't there. There isn't the time for it. With the best will in the world, your local science advisor has got a lot on their plate. Or your county archaeologist, if they've got the expertise in geophysics, they'll have a lot of other stuff that they need to be doing. They may not be able to get back to you at the drop of a hat. So how can we get around that? Well, in Scotland, we were talking about a possible roadmap approach for actually showing a map of the country with which techniques work where based on geology, soils. Not entirely relevant to this. However, the key here is using the knowledge that it's in the geophysics units up and down the country. Typically on a project, the geophysical contractor gets involved between the consultant developer and field unit who go out and dig the trenches based on the geophysics. So they come to us, they say we need a survey, we give them a price, we go and do it. That's the basic way it works. At that point then, quite often, we lose touch of that project. It disappears out of our door. We might ask for feedback on the trenching, but quite often, again, people are busy, it doesn't come back. Perhaps what we should be looking at is involving the contractors throughout the life cycle of a project. Get advice from us. We're not going to sell you a bad project. We're not going to sell you a technique that isn't going to work on your site. We're a small industry, archaeology. We rely so heavily on repeat business that it's not in our interest to try and sell you something just for the sake of it. Come to us and we can give you advice from that outset so you can better plan what you're going to do with your strategy. We'll then obviously produce a report traditionally, pass that on to the field unit. It might be that once you get on site and you start digging your trenches, that actually you're getting something quite unusual coming up. It might not be exactly as we've interpreted it. But if you were to give us a phone call and say, hey, I'm on site number blah, 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 your report, could I chat through with someone about the results that we've got? We might be able to say to you, oh yeah, actually in this instance we may have misinterpreted, so perhaps what you need to do is assume that features X are this, features Y are actually this. Come back to us, give us feedback. And then again, at the end, after the excavations are finished, if someone could just send us through a plan of the drawing, I'm onto it, we can then make our interpretations better in the future, because if we know when we're right and when we're wrong, that will feed into all of our future interpretations, and so we can progressively produce better and better results. So that's my 15 minutes of fame. Any questions?
You've given us a bit of a roadmap for the rest of today.
That was what I thought.
Thank you very much. And obviously illustrating some of the many questions that we need to tackle really as a group. Would anyone like to just simply have any clarifications, or just simply some very quick questions, or anything like that? If you would, it'd be good if you could say your name as well, because although I recognise the majority of you, one or two people.
I should just say that obviously all of those examples are magnetic survey, because I could grab hold of them pretty quickly. Other techniques are probably where we need to be moving towards, is using multidisciplinary approaches to sites. And as I said earlier, that is going to be something which will come through, I think, in the talks at the end of the day, where we look at other options.
Yeah, I mean, one of the things that certainly caught my eye there was really the concept of sampling is something that we desperately need to come back to and discuss, because it's one of those things that keeps on coming in and out of favour, you know, and it's kind of here is nobody's head.
Laughing, I think.
Laughing. Yeah. But of course, what we can see is the sampling is part of an overall strategy. The trenching was sampling. You know, we shouldn't be afraid of sampling. We should just simply discuss about the ramifications of this. You know, it's in a lot of archaeologists actually involved look at sampling not as what you've missed, but a prediction of what you've found. Okay, and that's a different approach to sampling.
For Ken Hamilton, Norfolk County Council, I think that Jimmy's dead right. With the whole point of how geophysics sits within an archaeological project, it's got to be an integral part of the whole project, and that ties in what you're saying about sampling.
Yeah, we don't always claim to be right all the time. Well, actually, I do. But.
Peter, I think one of the biggest problems we face is that we are often consulted as a specialist entity within an archaeological project. So
Yeah.
you bring in specialists at different stages of the project, like environmental sampling or radiocarbon dating or whatever, and geophysics is treated as a specialist aspect of an archaeological project.
Mm-hmm.
So we need to be more integrated within the whole project.
Yeah.
Yeah, but I wonder about whether that's really the way that the fragmentation of the discipline of archaeology really doesn't really necessarily bring that to the fore, does it? So any other quick questions, please? No? Yes? No? No? Please?
Nick Smith, London County Council, just a quick plug really, or a suggestion. Going back to your suggestion of reviewing data sets after the event, we was a curatorial body, we're sort of on the outside to some extent.
Mm-hmm.
We don't liaise all the time continuously with the geophysical contractor or fieldwork contractor, who might not always be the same contractor, but we are accumulating an archive of geophysical survey reports, some of which of course have follow-up work, and we're increasingly moving towards strip and record mitigation methodology, which gives us a better opportunity to review the results of all forms of fieldwork. We haven't found the capacity to actually review all that data and go back and see how effective it is all the time. But if anybody is looking for a research project or it's a data set, we've got on this topic.
You've got the money, pal.
We may have in the future, but
Yes, well, but I mean, obviously we'll hear this afternoon, I think, the outcomes of at least one of those sorts of reviews, and I think it's a crucial point, is that we have this information, but how do we get it back? We all agree that we should feed back and we should learn, but it's really and we all say it's there. But I think what we need to do is find mechanisms for opening this data up. I mean, obviously we'll hear a little bit about the information that's held in ADS, for example, and there's plenty of other archival areas where we could draw down. But I think the fact that you're thinking about opening them up is really important.
we have it for some time, but again, it's just resource and finance.
Absolutely, I'm sure. Okay, if you just stop there, because I'm very aware of the fact that people want to come in. Come in, please. Come in. Okay, thanks, Jimmy.
Yeah.
That's very good. You're off the hook now.
Thank you.
Okay, my next up is Duncan. Excellent. And let me see what Duncan's going to talk about: geophysical survey strategies, considerations, and case studies. Welcome, Duncan. There you go.
Time starts now. Right, this presentation was also originally developed for the Algae Scotland meeting a couple of years ago. I've changed it a bit, take out a bit of the Scottish emphasis. And you will notice a number of overlapping themes with what Jimmy was talking about. So really, probably what I'm going to talk most about is highlight some of the factors that should perhaps be considered when people are planning a survey or commissioning a survey. There's a number of issues, any of which can affect the outcome and the usefulness of this survey. So I'll talk briefly about some of the issues, and then we'll look at a few case studies. As you can see there, I'm part of a university field unit, so we're a commercial unit, and we're basically an income stream for the university. But on the upside, it means we do get to work on some of our colleagues' fieldwork projects. And that enables us to conduct some surveys that we we certainly wouldn't do on a commercial basis. And some of those examples will hopefully highlight some of the considerations we're going to talk about. There is already a lot of guidance out there, of course, already, English Heritage and IFA. The English Heritage guidance, of course, goes into quite a lot more depth than the IFA, just by the nature of the document. And I'm not going to reiterate stuff that's in there already, but I will discuss some aspects of it. So why do geophysics anyway? Certainly in the commercial world, this would be a fairly typical aim, I would have thought, to assess the nature and extent of any subsurface features of potential archaeological significance. And of course, that will then inform any further work. Now, in many circumstances, a geophysical survey will probably be the quickest and most cost-effective approach to realising that aim. It's not intrusive, it can inform further work, and it will help target areas for excavation. And one of the big advantages, especially for commercial work, is that we can get results on site. I'm sure many of us have been in a situation where we're surveying a field and there's a JCB 50 yards away waiting to put some trenches in. So very quick, very cost effective, on-site results, very useful. There are, however, as you say, a number of factors that can make a survey more useful or not. Perhaps the biggest concern is there an appropriate technique for your project, or several techniques for that matter, and that's going to be based on a number of factors that we'll come to in a minute. Is there a need for a sampling strategy? English Heritage preference is for 100% survey of a development area, but in exceptional circumstances, as they say, there may be a need for a sampling strategy, and if so, you need to think about what sort of percentages of an area you might be looking to survey. Do you need to change sampling intervals, things like that. The nature and the extent of the development as well, of course, will have a bearing on what you can or can't do, or areas that you might need to prioritise. So, of course, there's a number of different techniques available. Some will work in some circumstances, and some won't. So you need to be aware of the capabilities of the different techniques, and at least have a basic idea of how they work and what they're measuring. The techniques generally measure different physical properties of the soil. If you can use more than one technique, all the better, and that will help your interpretation. And it's not just the physical properties of the soil, we can detect objects as well. It's not often that we would do that on a commercial basis, although I have used geoscan gradiometers in the past, walking up and down a river to recover firearms, but I'm not allowed to talk about that, so move on. So these are the three most commonly used techniques: gradiometry, resistivity, the speed at which these appear gives you an idea of how fast they are in the field. Magnetometry, of course, very quick, and that is the sort of standard geophysical workhorse in Britain, except in circumstances where it's not suitable. Resistivity, again, a widely used technique, and of course radar as well, which in recent years is becoming a lot more common. So these are some of the factors to be borne in mind when you're planning a survey. It's always useful to have prior knowledge, of course, and if you have an idea of the nature of your likely targets, that might have a bearing on which technique you use. Similarly, an idea of the depth is very useful. If you know there's going to be colluvium or alluvium, you may be looking to use a deeper technique. Ground conditions are very important. Some equipment will go through crops, some won't. Some will go through hard surfaces, some won't, and so on. Again, this is the sort of knowledge that's easy to get before you start, not so much the earlier two. But also proximity of buildings and services. These will certainly have a bearing on any magnetometer survey. And the local geology and drift. I'm going to go through a few case studies of this. So yeah, a suite of techniques should be used whenever possible. That speaks for itself, really. No one technique is going to give you all the information. In the commercial environment, it's very difficult to persuade anybody to pay for more than one technique, of course, but it does happen. So the most commonly used technique, magnetometry, has traditionally not been used in some areas, quite a lot of areas, because of geological concerns. The sort of geological issues we have are essentially the igneous rocks, to some extent metamorphic rocks, although that's not been such a problem. But you can see the problems really are concentrated in parts of Scotland and the islands, Northern Ireland, Cheviot, Northumberland, down in the southwest. The rest of the country, really, you wouldn't expect it to be a problem, although you'll see there's at least one poster outside which does discuss some of the other geological issues. I'm going to use, this was a research project in Scotland quite a long time ago now, but I will just use some examples from here just to demonstrate how magnetic survey can be used over different geologies. This project was looking at the first millennium BC, first millennium AD settlement and economy. One of the spin-offs, or a secondary objective, if you like, was to look at how geophysics might be used in this environment. It's a very mixed geological environment. We have a big igneous feature there, Traprain Law itself. The geology around is very complicated. And we surveyed 30 sites, trying to sample different geologies as well as different types of site. The sites were all crop marks. Most of them were very clear. But partly to test the technique and partly to see what other features were present that weren't shown on APs. So this is a survey on basalt, and this is a magnetic survey, and the results are absolutely fantastic. The basalt here is only 30 centimeters beneath the surface, and yet we've got very good results, very clear results. In fact, inside the inner two ditches there's actually a row of post holes in the survey. I don't know if you can see that. And these were proven by excavation later on. And it picked up a number of features which weren't evident on the aerial photograph, and it was a surprisingly encouraging result. This is another one on igneous extrusive rock. Again, very clear results. Not what might have been expected. Probably not in a commercial environment. You might not have been using magnetics here at all. This is the same geology as the previous one. Some of it's been quarried away since the aerial photograph was taken. But again, very clear ditch circuits, overlapping circuits. Again, another igneous bedrock here, Chester's Quarry. We've got a reversed polarity here from what we would expect from a ditched enclosure, and it may be that this is, we didn't get to excavate this site. It may be that this is rock cut, and the fill is significantly less magnetically susceptible than the rock, permanently magnetized. A number of these sites we did get to do some excavation afterwards. This one's not so clear. This one again is on a sort of lava, a basalt, and you can see in the aerial photograph these sort of lobes where the lava's flowed, and again these are evident in the survey here. And again, the ditched enclosure here changes polarity as it comes across. Not a great example, that one. We did have mixed results, but even so, we've still got we've got the enclosure itself. Now, some of the more disappointing results on this project were actually on sedimentary strata. Again, it's perhaps not what you might have expected, but this one wasn't so bad. We've got a sort of small oval enclosure with quite a lot going on inside and a ditch out here. Just 100 yards away on the other side of this big field boundary was this site. And again, there's really, I've looked at that many times and struggled to pick out anything which matches with the aerial photograph. This is an area where you might think, let's do magnetics. It's sedimentary. It's away from the volcanic material. This is another one. Again, this is exactly the same rock formation as the previous slides, and yet here we've got perfectly clear results. So. Other geological issues then. When you look at a geological map, perhaps before you plan your survey, you might notice one or two igneous dikes on the map there. And in our experience, that usually means that there's an awful lot more than are shown on the map. And that was the case here. This was in Wales. There were no recorded dikes in this area, but clearly we found some. But again, I mean, I don't think this doesn't negate using a magnetic technique in that environment. We've picked up very many weaker anomalies, and the effect of these dikes is really no worse than a ferrous service pipe that we pick up in all sorts of situations. Just out of interest, we've got a little starfish anomaly there, which we think is a lightning discharge. So again, it's an area of igneous dikes, but that doesn't mean it's not worth doing a magnetic survey. I would argue that this is probably more of a problem. This is actually on chalk in the south of England, and this reticular pattern of anomalies here, positive anomalies, really does mask anything else that might be there. I mean, it's a bit of a nightmare trying to pick out here any potential archaeological features. It's you know, in many respects, this is more of a problem than the some of the igneous geology we've looked at. I'll keep pressing on. So the English Heritage Guidance, it is a few years old now, but most of it's still very relevant. And there is a preference for detailed magnetometer survey over the whole of the evaluation area. As Jimmy was saying, obviously that's what we would prefer. It makes things more efficient. It stops you having to go backwards and forwards to add on extra surveys. There are some situations, of course, where a magnetic survey might not be appropriate, and in that case there are guidelines in the EH document about different ways you might approach the site. And one way might be to do a pilot survey first. And I'll just show you one other example of a geological issue. This is an area of granite with known dikes in it. It was for a research project, but at the same time we thought, well, we don't want to leap in and start drilling out hundreds of hectares. So we did a pilot survey, magnetic survey. And you can see all these features here. They're very clear, but unfortunately we've got this granite shield over the whole landscape. But with just a very small amount of processing, we could remove that and reveal a lot more structures. This is part of a Neolithic site, and on the basis of this trial survey, we were then able to apply for funding. And we've now extended this survey over almost 300 hectares to get the rest of this site. But it would have been an awful shame if we just hadn't have bothered to think, no, it's not going to work. We're not going to do it. It's certainly worth it. Certainly worth a trial survey. Oh, I need to press on. Right, very quickly then. So some of the different approaches that are suggested in the guidelines, the EH guidelines, are maybe to do detailed survey of the known sites, magnetic susceptibility survey of the rest of the area, and then come back and do some more further detailed survey. And that was an approach that we did on this job, although it wasn't our project design, if you like, it was given to us. So we had a known area of archaeology up here, crop mark, another one down here, so we targeted those, the rest of the magnetic susceptibility, and then we went back and did other trial surveys just to confirm this pattern. which did work very successfully in this instance. This triangular area here is actually an old field. It was defined by field boundaries, and it's obviously had some sort of different land use to the rest. Let's whiz through that. The EH guidelines do say that if it's not possible to survey the whole site, for whatever reason, then you should still be doing a minimum of 50% detailed survey and fill in the gaps with other techniques. Now, this was an example in the south of England we did a few years ago. It was a real nightmare. Again, it's a scheme that was given to us. It wasn't our project design. It was already agreed, if you like, between the consultants and the county curators. It was a very big site. And it was agreed that 50% sample would do. These are actually 50-metre wide strips. So you can imagine, there's 50-metre gaps between these things. You can get all sorts of. Now, most of it was fairly blank, as you may or may not be able to see. Most of it's ridge and furrow, but every now and then you come across little farmsteads and so forth. Often we don't have the discretion, if you like, in the field to say, right, we need to fill in this gap. It's got to go back to the council, back to the client, consultant. Got to have a meeting and say, yes, we need to go and do another ½ hectare in that gap. These days, of course, with RTK GPS, it's not quite such a problem. You can go back very accurately and fill in these gaps, but it is a bit frustrating. And you can imagine if this was a 20 or 30-metre wide strips and you were surveying alternate strips, you've got to grid out the whole field in order to be able to do that. Very quickly then, some examples. This would be our preferred way, if we do have to sample something, is to survey blocks. And this gives you the opportunity to miss out pylons, manure heaps, etc., etc., any known hazards. So that's a 50% sample. There's really not much missing apart from the field boundaries, and a 60% sample. I mean, to my mind, this is actually quite worthwhile. All we're missing really is the field edges, the stream banks, wire fences and so forth. So there is something to be said for sampling, and I would apologise for running over. Very quickly, this was a staged approach, magnetic survey over the whole development area, targeted resistivity and or radar. Okay, that's clicked right. Apologies for running over.
Thank you.
Just quick clarifications. I actually have one. You showed some interesting differences on the sedimentary site, and obviously it's a conundrum where you say, we've got clear response here,
yeah,
poor response. Were they excavated?
Of the 30 sites we did.
No, in particular those.
No, they weren't.
Okay.
Unfortunately.
Because of course here's the conundrum, isn't it? Because actually, what's causing this? Is it the archaeology? Yeah. It's not. We can't just assume that there's a, as you say, we've got one type of geology. We're definitively going to find the clear outcome.
Yeah.
It's what's actually happened in the ground, isn't it?
Yeah, absolutely. And that project, in fact, threw up all sorts of questions, most of which we weren't able to answer within the project, unfortunately.
Right. Okay. Yeah. I mean, some really queer reversals and everything, which
yes,
it's very difficult to look at. Is there any other questions?
Peter Barton from Trust. I know that's been very good. I'm intrigued with the results that you've got on these igneous rocks, the various igneous rocks. Do you think it was because that it's using gradiometry with even over a large offset? In other words, there isn't much variation within the magnetic properties of the igneous rock, but you've still been able to see differences.
I guess that might be one thing. Yeah, certainly. Although we were still surprised, especially with the rock being so shallow. In nearly all the cases where we got to do any trenching, it was very shallow. But I guess it is very uniform, certainly the basalt at least.
So, I mean, we've done various bits and pieces, not a lot obviously, over igneous rocks, but one in particular down on the Lizard, which was just completely wiped out.
Yeah.
Any subtle features, just there. Yes. So you do tend to get a mindset if it's igneous, you don't bother. But I think another PhD subject for you, Chris, is to
categorise the different types of igneous
Yeah,
rocks
yeah.
to see
Well,
which
you know,
ones
we can see that certainly if you look at the igneous dikes, if you look at Tony Clark's classic survey up in Orkney, you know, he was what 3 or 4 meters away from that dike. You know, if that dike had been, you know, a little bit further south, you know, the iconic image from his original survey back in the, was it the 19, when was it? 1933, did you say? 1973, beg your pardon. Oh yes, of course, it was the famous English Heritage Survey in Scotland, wasn't it? Okay, let's move on. Thanks.
So I just messed this up, Chris, I think.
Have you? Whoa.
I was going to end the slideshow and put the new one on, but I think they've all been run together.
Technical support somewhere. What are we doing?
Should we?
Oh yes, I really don't
Yeah, back into the folder that
It must be where is it?
That one.
That one?
Yeah.
Okay, lovely. That one there must be.
All right.
That's it.
Let's settle down, everyone, folks. Settle down. We've only got about 15 minutes or so before we move to the first tea break. Okay, Hannah's going to give us some views on using geophysics as a consultant.
To be kind.
Yes, I was going to say that normally there should be a piece after the word consultant.
Yeah, right. Right, so I'm Hannah Smalley from CGMS. I'm a senior archaeological consultant. I do have a background in geophysics. I started my archaeological professional career as a surveyor. I've done the walking up and down the fields. I've produced the reports. I've processed and interpreted. So I'm in that unique position of knowing where you guys stand, and now I'm commissioning the work. So, company experience. CGMS are leading providers of independent heritage advice. We have 7 regional offices and commission an awful lot of geophysical surveys. I have detailed records of certainly what our Cheltenham office have commissioned, and in 2013 we commissioned over £110,000 worth of survey work. Overall, it's estimated that the company is around about £450,000 worth of work. We are getting even more busier, and geophysics seems to be the very first port of call for many of our sites to undertake. Last year we used 10 different geophysical survey contractors to carry out these works, and I think, as Jim has explained, predominantly relates to detailed magnetic surveys, just due to the fact that the majority of our sites are greenfield sites. It's a rapid and cost-effective approach to get an initial understanding of the archaeological potential of the area. I've been at CGMS for 7 years, and I could probably think of one residency survey we've commissioned. 2 MagSUS surveys. The last MagSUS survey I did in 2012. Both of those MagSUS surveys, there were over 350 hectare sites. They worked extremely well. So there is still merit for this approach. And this was undertaken at 20 metre centres, not the necessarily recommended 10 metre centres, the English Heritage State, but they were specifically targeting late prehistoric and Roman activity within the area, which I think everyone agrees is fantastic use of magnetic surveys for those areas. Right, I think we've touched on this already, and apologies if people already know how it fits in, but I think it's useful to have an overview provided by a consultant in how we try and assess these sites. So, geophysical survey often forms part of a programme of archaeological investigation undertaken to inform a planning application, proposed development schemes, or conducted as part of a condition attached to planning consent. In some cases, they are also conducted to inform clients of archaeological risk for potential development sites. So these may be very early sites. Examples that we're going through at the moment have loads of solar development sites, and they would like to initially identify, let's say, 20 sites might be possible, and then they'll reduce it down to 10 if they've got any designated heritage assets throwing up setting issues. They'll conduct surveys across those, and then they find some archaeology there, and it's just not financially viable for them to either miss the area with solar panels or cost in the mitigation for that, so they will just drop those sites. So we get lots of those as well. Right, this is mainly planning policy in England. We have the National Planning Policy Framework, which was adopted in March 2012, which replaced PPS 5, and before that PPG 16, 15. And underneath those, we've got the local planning policy, which essentially provides a little bit more detail, regional, local significant sites. We have areas of high archaeological potential that are designated in the local plan. I think the key phrase I've just nicked 2 paragraphs for the NPPF. There's only 2 pages that relate to conservation in the NPPF. It is related elsewhere throughout the document. You've got pages 30 to 32 that have paragraphs relating purely to heritage considerations in planning applications. And I've just highlighted a bit of text there. So where a site of which development is proposed includes or has the potential to include heritage assets within archaeological interest, local planning authorities should require developers to submit an appropriate desk space assessment and, where necessary, field evaluation. So the principal aim of the survey is to identify the presence or absence, extent and nature of archaeological deposits. The results will often form part of a programme of archaeological investigation. In many cases, but not all, desk-based assessments have been conducted in advance of this. Right, key priorities for commissioning surveys. They're in no particular order, and I'm sure there'll be lots of boos about which one I've put up first. Experienced professional units. We want the reporting to be recognised to professional standards. That is very key. If the local authority doesn't say that it's fit for purpose, it can't be accepted, and then we're starting from scratch again. Secondly, cost, and I'm sure a lot of you have thought, well, that should be number 1, surely. We're all working in a competitive market, and the same goes for my costs as your costs, and it is a key consideration for clients. Going forward, they can be extremely stingy. If they're looking at developing sites and they haven't got planning permission, they don't want to spend a penny. So it's very difficult to overcome that. I think availability, duration of survey, report completion dates, production, that's all the delivery times. And no matter how often we've advised clients that they need to understand the archaeological risk of a site as early as possible, especially when it's huge, large-scale infrastructure sites that can help inform